part of chapter 7.42 is looking at these partial fraction decomposition when the numerator is greater, the degree of the numerator is greater than the degree of the denominator. Here the degree of the numerator is 3, the degree of the denominator is 2. So what we're going to have to do is our division, long division. And long division is going to be a little bit easier to work with than synthetic division. So on the outside we get x squared plus x plus 1. Inside we're going to get x cubed plus 2x squared minus 1. And we're going to keep doing this long division until the degree of whatever's in here is less than the degree of the denominator, this here, so 2. Now, we do have to include all the missing terms here because there are a few. So one of the missing terms we'll have is plus 0x. And that's the only one we have missing, minus 1. Now our first thing when we divide is we need to see what times x squared gives me x cubed. Well, that'll be x, and I want to line it up just so it works out a little bit nicer. So we're going to multiply. So I kind of lined it up just so we have it nice and ordered. Now the next thing we're going to do is we're going to multiply through. So x times x squared gives me x cubed. X times x is plus x squared. X times 1 is plus x. And at this point here we're going to subtract. So x cubed minus x cubed cancels. 2x squared minus x squared gives me x squared. 0x minus x is minus x. And then we bring down the minus 1. Now the degree is 2. But since it still matches up, we need to go one more step, which will be what times x squared gives me x squared. Well, that's just going to be positive 1. So 1 times x squared is x squared plus x plus 1. And again, at this point here, we're going to subtract. So x squared minus x squared, this here cancels. Negative x minus x is negative 2x. Negative 1 minus 1 is minus 2. So this here is what we have left over, and because the degree of this is less than 2, we're done. We don't have to do anything, and well, we can't really divide any further than this here. So what that tells me is this here written so that the numerator is less than the denominator. We get x plus 1 plus negative 2x minus 2 over x squared plus x plus 1. Now the next thing we need to do is we need to factor the denominator of this here. We need to factor this denominator because now we do have it in a form where the numerator is less than the denominator. And we need to see what this factors to. So looking at this over here, we'll have x squared plus x plus 1. Well, it looks like there's a chance it might not factor. And instead of going through the process of trying to factor it, I'm just going to check it with b squared minus 4ac. Because if this is a positive whole number, the square root of b squared minus 4ac, because if we plug all this in and we get a positive whole number, not a decimal, then it will factor. And so when I check this here, so square root, well, our b in this case is 1, so we have 1 squared minus 4 times 1 times 1. And if I plug all of this into the calculator, I will get, well, simplifying it down, 1 squared minus 4 times 1 times 1, I get negative 3, which is I square root of 3. Now what this tells me is that this here is not factorable. So I can't break it up, I can't factor it. So that's as simplified as it gets. Which means that because this is the only set of factors in the denominator, we are done. This is it here. Now if it turned out that I had another set of parentheses in here, like there was a greatest common factor of x, then we could split it up a little bit further, but because the only thing in the denominator is not factorable, we are finished with this here. Now we're going to look at another example of these here in a minute, but that's all we have to do for this problem. So let's look at another example. Now we're going to keep looking at examples of these here. Now this next example, you should note that the degree of the top is greater than the degree of the bottom. the degree of the top is greater than the degree of the bottom. So what we're going to have to do is we're going to have to do synthetic division or long division. Now, because the degree of the polynomial is 3, we do have 3 terms here. It's going to be easier to use long division. Now, what we're going to want to do with this here is we're not going to want to solve it all the way down. We just want to use long division enough so that the degree of the bottom is greater than the degree of the top. So we'll have x cubed plus 2x squared plus x. And inside we have x to the 4th plus 2x cubed plus 6x squared plus 20x plus 6. So for this here, because the degree of the top is only 1 greater than the degree of the bottom, we just need to do this long division once. And so what we're going to have is x, because again, when we do long division with polynomials, we're trying to see what times x to the 3rd will give me x to the 4th, and that works out to be x. So we multiply through. X to the 3rd times x is x to the 4th. X times 2x squared is plus 2x cubed. X times x is plus x squared. And again, at this step here, when we do our long division, we're going to subtract these here. And when we subtract them, x to the 4th minus x to the 4th cancels. 2x cubed minus 2x cubed cancels. 6x squared minus x squared gives us 5x squared. Now, is this degree less than the degree of the bottom? Yes. And we always want it to be less than, not equal to. So if this had worked out to be a 3rd power, we'd have to do another one. But here it worked out to be a 2nd power, so we'll bring everything down. Plus 20x plus 6. So what we want the partial fraction decomposition of is x plus 5x squared plus 20x plus 6 all over x cubed plus 2x squared plus x. This is what we're working with now. This is what we're trying to find the partial fraction decomposition of. And when we set it up, we'll see what we're going to do. We're not worried too much about the x, this x here. It'll come in later, but we're more focused on finding what this breaks up into. Now, the first thing we need to do is we need to factor the denominator. We need to factor the denominator. Now, I'm going to do this over here on the side. So x to the 3rd plus 2x squared plus x. And looking at this here, when we factor it, well, we should notice that there is a greatest common factor of x. And we'll factor it out. And when we factor that x out, we get x squared plus 2x plus 1. And so now we're going to factor this here. Well, since it's plus 1, our signs are the same. Since the constant term is positive, the signs are the same and they match the sign of the middle term, which is positive. Factors of x squared are just x and x. Our factors of 1 are 1 and 1. So we get x plus 1 and x plus 1. Now, if we want, we can really simplify this down to x times x plus 1 squared. And that is what the denominator here factors down to be. So really what we're trying to look at and what we're finding the partial fraction decomposition of is x plus 5x squared plus 20x plus 6 all over x times x plus 1 squared. Now, when we're doing our partial fraction decomposition, we're not looking at this whole thing here, x plus this. The only thing we're really looking at out of this entire thing is this part here. The only thing we're looking at is this part here. Now, I'm going to use the magic of copy and paste to bring this down. Now, when we plug back a, b, and c, we're going to add the x back to it, but we just want to find the partial fraction decomposition of this part here. Now, up to this point, we've been doing 2. We've had at least 2 fractions that we're adding together. Here, we're going to have 3. And we'll see why that is here. So we're going to have 3. Now, one of the factors of the denominator is x. Another one is x plus 1. And last but not least, our third one is going to be x plus 1 squared. So because we had 2 of them, we're going to have x that's by itself, x plus 1 and x plus 1 squared. We have 3 terms. Now you might be thinking, why don't we just have x plus 1 and then another x plus 1? Well, we need 2. We need x plus 1 and x plus 1 squared. We need both. Now again, the overall degree of what's inside here is 1. The degree inside here is 1. The degree inside this here is still 1. The only reason we would need anything more than that is if we had a quadratic that didn't simplify. So if we had x squared plus 2 inside the parentheses here, then we would have a variable on top. But because in each side of these here, it's only 1, we're only going to have a, b, and c. And that'll make more sense when we come across it later. There will be a problem with that. Or an example problem we'll look at with that. So we have this here. Now we're going to do the same step. Our next step will be the same as what we've done before. We're going to multiply each term by the greatest common denominator. So x times x plus 1 squared. X times x plus 1 squared. X times x plus 1 squared. And x times x plus 1 squared. Well, these here are going to cancel. X and x is going to cancel. X plus 1 is only going to cancel with one of these here. And x plus 1 squared is going to cancel with our x plus 1 squared. So what we're left with is 5x squared plus 20x plus 6 is equal to a times x plus 1 squared plus b times x plus 1 plus c times x. So we have this set up here. Now looking at all these here, so we have 3 different spots we need to look at for what values of x we need to pick. So we have one here, here, and here. Well, the last one tells me that one of the values I'm going to pick is x is equal to 0. X plus 1 tells me I'm going to pick x is equal to negative 1. So we're going to have these 2 different spots here. And x equals negative 1 is going to be the first one we look at. Or sorry, x equals 0 is the first one I'm going to solve or check and do first. Now when we do x is equal to 0, we're going to plug in 0 for x. So we're going to have 5 times 0 squared plus 20 times 0 plus 6 equals a times 0 plus 1 squared plus b times 0 Okay, so we have these 2 here. Now the first one I'm going to do is actually negative 1, not 0. We're going to go through negative 1 first, and then we'll do 0 later. So we're going to do negative 1 first. Now this is going to take up a lot of this screen here, so I'm going to have to probably erase it. So we have 5 times negative 1 squared plus 20 times negative 1 plus 6 equals a times negative 1 plus 1 squared plus b times negative 1 times negative 1 plus 1 plus c times negative 1. Well, negative 1 squared is just 1, so we'll have 5. Negative 1 times 20 is negative 20 plus 6 is equal to, this whole thing here is going to become 0. This whole thing here is going to become 0. So all we have left is negative c. So we could simplify this side here. So 5 minus 20 plus 6. You can plug this into a calculator or do it by hand. It doesn't matter which. we will get negative 9 is equal to negative c. And at this point here, we would divide both sides by negative 1. And when we divide both sides by negative 1, I get c is equal to 9. I get the value of c is 9. And so we've solved for one of the values, our letters, and we found c is equal to 9. Now at this point here, again, I'm going to erase all this here except for what c is, because we're going to need space to do the other one. So we plugged in negative 1, we got c is equal to 9. Now at this point here, I'm going to use this for our next one here, because I know what the value of c is. C is 9. So when I plug in 0, I'm not going to plug in the letter C here. I'm just going to go on and plug in 9. I'm going to substitute that back in. So when we do our next one, when we plug in 0, we're going to have 5 times 0 squared plus 20 times 0 plus 6 is equal to A times 0 plus 1 squared plus B times 0 times 0 plus 1 plus 9 times 0. Well, this here is 0, this here was 0, so 6 is equal to A. 0 plus 1 is just 1, so we have 1 squared. This here is 0, and this whole thing here is 0. So we get 6 is equal to A times 1 squared is just A. So 6 is equal to A. 6 is equal to A. So we have this here. So we have 2 of our letters. We have 2 of our letters here. Now again, I'm going to go on and erase this here, since we used that. Take those together. So we plugged in x is equal to 0, we got A. So I'm going to erase that here. We got 6. Now the next thing you're probably saying is, well, we still have B. We still haven't found the value of B. Well, at this point here, again, what we said on the first time we did one of these here, both of these sides are equal. This is an equality. So any value of x I plug in will work. And since we've already found A and B, we only have one letter left to solve for. I'm just going to pick a value. 1. Now again, you're wondering, why didn't we do this from the start? Well, we picked these two because how many variables, or sorry, not variables, but how many letters did we have to solve for? We had to solve for A, B, and C. We had 3. And it worked out. Negative 1 eliminated 2 of the variables out, A and B, leaving us with just C is equal to, where it was the only letter left, the only letter left that we're actually solving for. When we plugged in 0, it canceled all of our letters out, all of our variables out, except for A, and we were able to solve for A. Now looking at this here, when I set x equal to 1, what's going to happen? We're going to have 5 times 1 squared plus 20 times 1 plus 6 is equal to 6 times 1 plus 1 squared plus b times 1 times 1 plus 1 plus 9 times 1. So I plugged 1 in for x. How many variables do we have? Only 1. The only one we have is b. Everything else is a number. And we can simplify this here. Well, 1 squared is just 1, and 1 times 5 is 5. 20 times 1 is 20, plus 6. 6. 1 plus 1 is 2, and we have it squared. Plus b times 1 is b, and then we have 1 plus 1 gives us 2. And 9 times 1 is 9. Now I'm going to add all of these together over here. 20 plus 5 plus 20 is 25, plus 6 is 31. 2 squared is 4, plus 2b plus 9. Now 6 times 4 is going to give us 24, plus 9 plus 2b. I'm kind of rearranging so our like terms are next to each other. 24 plus 9 is 33 plus 2b. Now at this point here, we're going to subtract 33 from both sides. And when we subtract 33 from both sides, we get negative 2 is equal to 2b. And last but not least, we're going to divide both sides by 2, telling me that negative 1 is equal to b. Now we found all three. And I'll bring the other two down here. So here are our three letters that we have. Don't need that. So these are our three letters that we have. Now I'm going to scroll back up to the top. So this here. Oh, going the wrong way. So not all of this here is part of our partial fraction decomposition, but we do have most of it here. Erase that there. So this is part of it, but we also had one other thing. Because remember, we had to divide first, and when we did our division, we got x out front, so we're going to have it still here as part of our partial fraction decomposition. We need it still. Plus, because this plus part right here, I'm going to scroll back up, took the place of this part here. So we're looking at this. Copy that and bring it down here with us. When we're looking at this here, this x is still part of it because this whole thing here is this fraction. These three parts make up this. Because when we add these three together, we will get this fraction here. So we still need the x. Now our value of a, we found it to be 6, so I'll plug it in. Now the value of b, we found to be negative 1. And the value of c, we found to be 9. So our partial fraction decomposition is this thing right here. And that's all we have to do for this problem. Okay, so we're going to look at this here, and this here will be the last example we're going to look at in 7.41. Now, when we look at this here, we see that the degree of the numerator is greater than the degree of the denominator. So again, just like the previous problem, we're going to have to do long division to simplify it so the degree of the top is less than the degree of the bottom. So we'll have x to the fourth plus x cubed plus 0x squared plus x plus 4. So we've got to fill it in 4, 3, 2, 1, 0. And outside we're going to have x to the third plus x squared. So we're just going to have the 2. Now again, when we divide, the first thing we're trying to find is what times x cubed gives me x to the fourth, which will be x. So we have x times x cubed is x to the fourth, plus x times x squared gives me x cubed. And at this point here, we would subtract. X to the fourth minus x to the fourth is 0. X to the third minus x to the third is 0. So we bring everything else down. Well, we bring down the 0x squared plus x. Well, the degree of the numerator is less than the degree of the denominator, so we're done. So we can bring the whole thing down. And what that tells me is that this here simplifies to x plus, the top is, well, we don't worry about this one here. We just have x plus 4 over x cubed plus x squared. And so now we have it simplified so the degree of the top is less than the degree of the bottom. Now our next step is to factor the denominator. X cubed plus x squared. Now the first thing I notice is that they have a greatest common factor of x squared, and when I factor that out, it leaves me with x plus 1. We have it factored. So this one here is working out to be a little bit easier. and factoring than the one we had before. So once we have it factored, we have x plus 4 over x squared times x plus 1. So now when we break this down, we're going to have x plus this time again, we're going to have 3 fractions. Because what we have is x squared, and x plus 1. Again, because we don't have a quadratic of any type, we don't need more than one letter for any of these here. And so what we'll have is just A, B, and C. And now we're going to solve this here, solve for the values of A, B, and C. Now I'm going to use copy and paste and bring it down so I can work with this here. Now looking at this here, the one thing we're not going to worry about is this x and this x here. We'll bring it back into play when we get the answer, but we're mainly focused on are these two parts here. Well, I'm going to move this a little bit closer. I'm going to try to move this a little bit closer together. There we go. Now again, like we've been doing with the rest of them, the first thing we're going to do is multiply by the greatest common denominator. So we're going to multiply the whole thing by x squared times x plus 1. X squared times x plus 1. X squared times x plus 1. And finally, x squared times x plus 1. And when we multiply this all together, well, these here cancel out. One of the x's cancels out with one of the x's. X squared cancels out with x squared. And x plus 1 and x plus 1 cancels. And what that leaves us with is x plus 4 is equal to ax times x plus 1 plus b times x plus 1 plus cx squared. So we have our 3 here. Now looking across these here, well, the x squared and x tell me for those to cancel out, I'll set x equal to 0. And for these here, the x plus 1 and x plus 1, for them to cancel out, we'll set x equal to -1. So we have these two here. Now we won't get the third one till later, because again, as we saw in the last one, we'll have to pick another value eventually to solve for whatever letter is left over. Now the first one I'm going to do, again, kind of like the last one, I'm going to do -1 first. It doesn't matter which order we do it. We could do 0 first or -1 first. It doesn't matter. So I'm going to do -1 first. And so I'm going to plug that in. So what we'll have is -1 plus 4 is equal to a times -1 times -1 plus 1 plus b times -1 plus 1 plus c times -1 squared. Well, this here and this here will both become 0. So what that leaves us with is, well, -1 plus 4 is 3 is equal to c times -1 squared is 1. So really we have 3 is equal to c. We have found the value of c. And that's all we need to do for that part there. So again, I'm going to erase everything else just so I have more room to work with this here. I'm going to leave this here. So when we plugged in -1, we found 3 is equal to c. So I'll come back up here and plug in 3 for c. Now we can do 0. Plug in 0, so we'd have 0 plus 4 is equal to a times 0 plus 1 is equal, or plus, not equal, plus b times 0 plus 1 plus 3 times 0 squared. Well, a is going to cancel out because of 0 multiplying by 0, And this one here is going to cancel out because of our multiplication of 0. Well, 0 plus 4 is 4. Is equal to, well, this is gone. 0 plus 1 is 1, so we have b times 1. And everything else is gone. So we have 4 is equal to b. And that's all we have to do for this part here. So we have our second value. And again, I'm going to delete the rest of this here. And that line. And we can plug in that value of 4. Now we need to find a. So I need to pick one more value of x. Well, why not 1? 1's an easy number to work with, so why not we just use 1? And we're going to plug it in. So we'll have 1 plus 4 is equal to a times 1 plus 1 plus 4 times 1 plus 1 plus 3 times 1 squared. Well, 1 plus 4 is 5. A times 1 is a, and then 1 plus 1 is 2, so we're just going through and simplifying. Plus 4 times 2 plus, well, 1 squared is just 1, so we have 3 times 1. Here, a times 2 is 2a. 4 times 2 is 8, plus 3 times 1 is 3. A is equal to 2a. 8 plus 3 is 11. So at this point here, we can subtract 11 from both sides. And when we subtract 11 from both sides, we get that 2a. 5 minus 11 is negative 6. So at this point here, we can divide both sides by 2. And we get that negative 3 is equal to a. So now we've found the value of all 3 letters. So I'm going to move these down here so we have all 3 down here, A, B, and C. And again, what were we trying to match this up to? We were trying to match it up to this here. So we have this here with our A, B, and C. Now we don't need the equal sign, but we're looking at this here, and at this point here we can plug in the values for A, B, and C. Now A was negative 3. B, the value of B is 4. And the value of C is 3. And that's all we have to do for this here. So that brings us to the end of chapter 7.42. Your homework assignment is on page 508, problems 43 through 48 all.